recording. All right, so I am now recording. So I'll repeat that, I guess. Recording. All right, so we are recording, and I just want to say again, remember we're on week 5, and this week we'll be doing a little finishing up cron and a few other miscellaneous things, and then starting DNS. The DNS lab is a fairly long lab, so it's really your first. Now that you've had 4 or 5 weeks of Linux, this is where you prove yourself, right? That you can actually do things in Linux as your first mini little complex project of configuration, etc. Right? So we'll do that, but key item is that the exam is February 15th, exam 1. It'll be from 2 to 4 on Brightspace. Okay, so log in for the first 5 minutes or so of the class from 2 to 2:05. I'll give the indications, any relevant things about the exam, and then you can just go on your own and work on the exam until 4, when you must submit on Brightspace and not via email. You can contact me via email if you have any questions, right? So that's the plan. So the exam will cover, I'll definitely get to DNS. If I don't get to DNS today, I will get to DNS on Wednesday. And I'll give, at least you'll have some lecture questions, right? You may not have lab questions, given that the lab may need to, begin, you won't have completed the lab, I guess, before the day of the exam. So I wouldn't ask that many questions, but lecture questions, sure. DNS will be one of the first services that we will look at. It's a pretty nice one. Linux has something called bind. So it's the service for DNS. So we'll take a look at that and the configuration. Should be pretty fun. You'll need, I should stress, you will need the seed labs for this one. And you need more than one VM. So right now, if you can start creating a clone, at least, so you will at least need 2. You may actually need 3, but we'll talk about it. So this is, as I said, we're starting to look at now, things where you have 3 computers or so networked together in a LAN type of a situation, a switch or a hub, and so you'll have to start. But it's a very nice lab. It's got, I know you guys love like cybersecurity, and it's got cybersecurity ideas in there. So we'll definitely take a look at it today. And then later on, when you do your network security class, there are more advanced DNS type problems in that course. All right, so let's see. Yeah. So that's it as far as the exam, which is the most important reminder for today. Are there any questions about the exam, guys?
I don't think so.
Nope. All right, great.
I got one question about the exam, actually.
Go ahead.
What can we expect? Is it going to be like fill in the blank, multiple choice, stuff like that, or is it more like?
Yeah, it's a good question. It's not fill in the blank or multiple choice. It's more like problems or essay type questions, or it could be like a script. So for instance, a good example of it is cron, right? We did last week. So I might give you the cron entry and you tell me what it does, like we did in the class, or I might give you the problem and then you write the cron entry. You see
Okay.
that?
Yeah.
So that's an example of a problem. It could be as straightforward as explain, one of the topics that we've covered. What is the UNIX way? That kind of thing. And also make sure you should be reading the slides. Okay, so remember that the slides are pretty much kind of read on your own. There's nothing for me to explain. They're just really like managerial things. For instance, if you have a help desk, be courteous with your user, those kinds of things. So make sure that you're always reading the PowerPoint slides, which I took a long time to summarize the book into those slides. Okay, so the managerial, and then I usually then just use the time for the technical things of Unix. Okay?
Okay, thank you.
All right, great. Great question. If you have the whole, you need extra time for the exam, what I usually do is I I do like what I do with the late thing. So what I do is, you know, it runs from 2 to 4, but then it'll stay open depending on what your extra time requirement is. It'll stay open, but it'll mark you as late, right? So if you're a student that does not have approved extra time, you should not submit after because it's going to mark you as late. So only I check that if it marked you as late within the time, it's because you have approved extra time, right? So be mindful of that. That's only for approved time. Obviously, it's, you know, I can't control what you look at on your end. So it's open book, but what I can tell you is that I do put in a lot of questions there so that if you start looking up questions on Google that you don't know, you're not going to have time to finish the exam, right? So obviously studying, creating a cheat sheet, having your materials. Usually my exams are closed notes, but with an allowed cheat sheet. You know, given that we are on the pandemic situation, at least this semester, you know, you can have your notes, but study still, be organized. Okay, any other questions, guys? All right, sounds like there's no additional questions, so that means everything is clear. So now let's switch back over to Brightspace, just so that we know where we are. So here is, you should be seeing Brightspace now. And I'm gonna go to content. All right, so as you can see, you know, read through all of this intro, make sure you go over all the managerial, you know, finish up what do system administrators do. Take a look at that. You know, take a look at, you know, the background software for Python, make sure, although we've done some examples of that. Make sure you look at the UNIX way, right? We discussed that. The workstation service and services, I've discussed that. Make sure you look at your Wireshark readings. There could be some questions about that. Pretty much everything in the labs, obviously. Could be questions about that. Task scheduling and cron, right? There's the lecture. Make sure you also read data centers and networks. Some nice pictures there of networks and such. So take a look at that. All right, and I think we've covered pretty much all of this, right? All of this last week. So now, today, this week, so you can see before I jump into DNS, which are, you know, here are the slides. And I think DNS doesn't have a managerial component. We need to look at grep and awk. All right, so this is one of the miscellaneous topics that we need to cover today. As you can see, I've already provided the data, and I think, you know, for you to view these, you have to download it. For whatever reason, it doesn't open them on Brightspace. But if you download them, it should be there. And it's basically my notes from today are here. Or it's coming from the book, you know, if you're following along in the book, you know, that's also there. All right, so today we are going to kind of actually start with task scheduling and cron, just the last few little things that I didn't cover from last week. I'll wrap up here, and then we'll move into these ideas. So grep and awk is actually several things, but I usually just call this module grep and awk because it sort of captures the whole, you know, the whole essence of it, I guess. All right. So anyway, so certainly I'm hoping the exam would cover at least up until grep and awk, but I do believe on probably today or on Wednesday, I will get to start the DNS. And as you know, DNS is just a service. Now, you guys already know about what DNS is, in fact, but we're just going to take a look at it in a more interesting way from a system administrator point of view. You know, configuration, obviously that means configuration in Linux, and then also some interesting problems, you know, related to like security, which I know you guys love that. All right, so what I need now is I'm going to switch over to the whiteboard. All right, remember my notes are in the slides already. Okay, so here is the whiteboard. All right, and, the topics, grep and awk and cron. So let's just, last week we were talking about cron and cron tab, right? And we did all those examples of cron tab entries. So make sure you understand those pretty well. So just to kind of summarize cron and cron tabs, we said that we can use the cron tab E command -E, right? That's to load the editor. So basically, this is how we can access our file. Okay. What is this? Okay. All right. So just remember that whenever you write into the cron tab, you are overwriting all the other entries. So you want to keep the entries that you had in there before. Okay. Now let's just say we discussed how we can use cron to automate. So cron used to automate tasks. Okay. So basically to automate tasks, in basically system administration tasks. Okay. So let's just, to remind you, so let's look at one example. So if I write this one, bin sh var, let's say var log daily .txt, and then 2.1 pipe, and this should not be txt, but it's an actual .sh, and then mail root. So what is this doing? What is this task for? So remember, these are the types of questions you will get on the exam, right? So I might just give you that and say, okay, what is this for? Anyone? So here you run, change colors, you run sh, right, which is a symbolic link. So we'll talk about symbolic links today to bash or dash, right? And then we call that program, which is basically like calling Python. So it's similar to me there calling Python or Perl, but I'm calling shell, right, which is a symbolic link to bash. And then I call the script, this one, daily.sh. That script then does this. What was this again? It's
Redirection.
You grab what? The standard error and the standard output, and then you pipe those, and then you send an email, right? So that somebody gets a notification. And then what about this part over here? What does that mean?
Every day at 1 a.m.
Every day, very good. Every morning, right, at 1 a.m. Right? So run the daily.sh script every morning, as you said, at 1 a.m. Very good. All right, so just a reminder there of the type of questions you might get on the exam. Let's do a couple more, and then we'll move on to something else. Let's say I do 0 to bin sh var log weekly.sh, And again, 2, 1, pipe, mail, root. All right, so what about this one? So obviously this part is sort of the same, running a script, redirecting the output, piping it into the mail system for an email. So what about this part over here? When is this running supposed to be?
So it runs Monday at 2 a.m.
Very good. Right, so you run the weekly .sh script every Monday, right? Monday at 2 a.m. At 2 a.m. Very good. And then one last one. So let's say, let's do this here. Let's do 0, 3, 1, asterisk, asterisk, bin, sh, var, log or someplace, monthly, .sh, again, to redirect, 1, pipe, to main, root. All right. So this will be pretty much the last one, I think, of this, and I will consider this topic concluded. So what would you say this one does?
Run the monthly sh script and redirect the standard error, standard out to main root every month at 3 a.m. at the first of the month.
Okay, on the first of the month, right? Very good. Exactly. Perfect. Very good. All right, so this one runs monthly on the first day of every month. And that's why it's called monthly, right? At 3 a.m. Very good. And this could be anything. You run those. Remember what I've shown you already how the scripts work. As we go forward in the semester, we'll just add more libraries to those scripts, more functionality. What kind of data are we trying to collect? We'll even kind of link them up with SNMP protocols, more advanced types of things. So it should be pretty good, pretty powerful. Really, is what it is. All right, so that sort of concludes the examples of cron. And now we're just going to touch on a few miscellaneous cron topics. So basically, obviously, the central mechanism of Linux is access control as far as security, right? Everything we've said is a file, and then every file has to have an owner. It has to have it has to have not just an owner, but permissions associated with that owner, with the group that it's group settings, and also with the rest of the world. So there's basically also in cron, cron has security issues. So cron security. Cron security issues, right? And you can make sure that only authorized users have access to put in commands in cron. As a system administrator, when you start managing a user, that's an important thing, right? That you can restrict what users may be allowed or disallowed. So in the cron settings file, remember that all configuration really in Unix is basically text files. That's exactly what you're going to start to see now as you will start configuring much more complex services, right? So far in the semester, you really just did like sudo apt get install, boom, done. All your troubles were gone, right? But now it's not going to be like that. You might have to do sudo apt-get, but then you will have to go in there and modify the settings, right? And that involves changing text files. So in the cron settings files, you will basically, go into the text file and look up, parameters, right? So in that file, this is addressed basically by a setting called cron.allow or cron.deny. And basically, this is kind of the idea with a lot of Linux is that you basically provide a list, right? So a list of users. So you usually get the user name or ID and you add them to either the list of users for deny or the list of users of allow. And that's pretty much how Linux works, okay? Linux works in this way. All right, so now that we've talked a little bit about cron, last week, if you notice, one of the examples that we did was to run via cron, we ran a Perl script, right? A Perl script. And then if you notice, that Perl script was calling itself syslog. All right, syslog is another service, just like, it's a service. So that's why one of the first lectures or labs that you did was related to looking up all the services in Linux, and then you look for the corresponding port numbers, right? The TCP, UDP port numbers, because that's something that you kind of want to start memorizing, right? Not just port 80 and port 22, but a lot of the services. And I've shown you already ways that you can check, you can start a service, stop a service, check if a service is running, check if the associated port number is running, and so on, right? So that's really the game in sysadmin when you talk about the roles of servers, right? So what do they do? What ports are open? And again, that's why we learn all these little mechanisms that make our lives easier. So today, so you saw in that example that we were calling syslog the service, and then syslog was writing to the file system to var log, and then I can't remember, I think it was syslog maybe, the file, right? There was a text file in there, and that text file contained, I think you wrote your name, or you wrote Purdue, or you wrote something of interest to you into that file, right? So basically, you have a service, let's just say most normal system facilities, so most services, in Unix, generalized to Unix. So most services in Unix all generate messages, right? So generate, messages, information that is recorded in logs, okay? And this just happens as they're operating. It doesn't even have to be an error. It just, as they're in the course of their normal operations, right? In addition, they report error messages whenever there's some kind of a problem as well. And then those are recorded usually in logs, and that's what we saw in that example, right? Because you wrote something intentionally, but you could also see that log was full of data. So monitoring such messages and acting upon them, of course, as the system administrator is one of the tasks, right? So a sysadmin, it's a very important activity to be able to monitor those logs. And that's why I've already shown you some scripts of how you can read data from these logs. Keep in mind on the exam, I could give you a problem like that, like that. Find some data in a log, write the script for it. But the idea is that you have the file, this one, and then you have some kind of a service, right? The service is, you can think of it as a protocol. And the great thing about this is you can have a network of computers. Maybe you have routers, printers, switches, etc. but you have one server that is a dedicated syslog server, right? So you configure these as clients, if you will, right? Clients, and then you can, configure this as the master, and then basically whenever something happens here, oops, maybe I should use different color. So here the traffic, network traffic, which is basically packets, are going to start sending their data onto that syslog server, right? And then as a system administrator, you will then monitor that syslog server for information, whether it's normal operations or error. This allows you to aggregate all that data for your use. Okay, so that's an important sysadmin tag, monitoring the logs. Okay. So we've talked about that service. Now, let's now move on. We are sort of at this point done with cron, okay? And we can just move on to a few definitions of a few additional topics in troubleshooting. And then from there, that should lead us into grep and awk. Because if you look, the progression kind of makes sense. We go from the system, right? The system, all the facilities. Let's say DNS is running, and then Apache is running, right? These services are running. Then you've got both the built-in applications, but also you have scripts like Perl, Bash, Python. They communicate with the syslog service, and they write data onto the logs, like syslog, which are text files. So then, therefore, as a sysadmin that wants to monitor the data, the next thing you need to do is be able to find data, grab data, or how it's called in Linux, grep data. So you're going to grab data and then report or analyze data, monitor it, etc. Right? So that's your daily task. So we are sort of going in this direction now, and we're just going to provide some definitions before we arrive at that. Okay? Or we arrive at that. So let's go ahead and continue here. All right, so just making sure I'm recording, and I am. Okay, so let's talk about a few little things here. So let's kind of circle back to the idea that we have in Unix. In Unix, we have access control of files, right? Of files. So one of the key things is, this, security also can sometimes, affect you, right? So security can sometimes constrain you because you can't do something because of the security that you have in place or the access control. So this, let's just call this how to recognize a file access problem. So how to recognize a file access problem. Okay, so that's the idea. So file access problems, because everything is a file and because of access control, file access problems are really common. Problems in Unix are very common. Okay, so what that means is that a lot of the time when you have a problem and it's not working and you're like confused, why is this not working? It should be. It's a lot of the time is because a lot of the time it's because of file access problems. The access control is not correct. Okay. All right, so file access problems are common. A good way to know is to test, and so the solution to this is a good way to know, to figure this out, is to test as root and as regular user. Regular user. So you can test as root. So basically, if something doesn't work and you're seed, do sudo, right? You sudo up, you escalate your privilege. Does it now work? Then you do ls-l, you look at the permissions, and that's usually where a problem will happen, okay? So this is kind of its own little topic just because it's such a common thing, right? That, you might spend, 30 minutes trying to figure out what the problem is. You don't get it. It usually is, it's a file access problem. And a good way to figure this out is to test as root and as regular user, okay? All right, so let's move on here. So in conclusion, after all of this that we've said, in Unix, it is reasonably safe to say that everything is a file. It's like the slogan, right? So everything is a file. Everything is a file. Even input-output devices are represented as files, right? So they're, and they're really just like regular files, like text files. Directories, I don't know if you realize that, but even directories are files. Directories are files themselves. A directory is a binary file consisting of a list of the other files it contains. So you can see it's really, a directory is nothing more, as it says, it's binary, but it's really just a file that tells you, okay, the address of these other files that I have. Devices, all kinds of inputs and output devices, they're represented in the system as files, basically. Okay, so the next thing we're going to look at is, I hinted at this before, is links. Links is another construct that exists in Unix. Okay, so Unix has this idea of hard links and soft links, but basically, let's call them symbolic links. And a link is, so a link in Unix is a mechanism. A link in Unix is a mechanism that allows several file names to refer to a single file. A single file, okay? So basically, it's like, I have a single physical file here, but I have, it can have several names, okay? So the example that I gave you, sh, right? Well, this is actually called bash, right? So the physical file is bash, but you have another file, which is, it is, because everything in Linux is basically a file. but it's actually a link, a symbolic link. And all that file does is it points to the actual file. So why is this useful? It's useful because whenever you run things, you probably just want to say sh my script, but maybe you use bash and a new one comes out called dash, right? So instead of having to change everything, all you do, you can break the link and create a new link to dash. So now whenever you called sh, this sh over here, you will be calling now dash instead of bash. Maybe then, you get tired of dash, and so you want to go back to bash, and you just create a symbolic link to it. And that's how it works. This is also useful in configurations. You will encounter this problem in your project A, right, where you have to configure Hadoop, because you will have, let's say in the configuration, a variable called Java. But the Java variable, it's really just going to be a symbolic link to a specific Java, like, JRE 2.7. Whatever, ... And so it's just going to be a symbolic link to this file itself. So that's very useful sometimes, this little trick in this little trick called the link or symbolic links, basically. Okay. All right, and later on we'll see how to break symbolic links. It's basically a simple command, and I think it's the ln command, if I remember correctly. ln, and then it allows you to say ln-s, and then you link the name and the file, basically. But we'll look at examples of that a little later. All right, another term that we probably want to define a little bit more clearly in Unix is the socket. We've already started to use this, right? We started to use this when we needed to scan IPs and ports, right? So in Unix, let's say, there are special types. There are special types of files, right? Which are used for communication between processes. So there are special types of files used for communication between processes. Right, so remember that a process is, let's say you start Apache or you start a script, right? Whatever it is, some kind of process. So sometimes you have a file in the system, a socket, and then basically both of these can send out information to it. Then maybe this communicates with a printer. All right, so the idea is they're really just endpoints, like a tunnel, right? So this is established tunnel between, that. And then whenever something wants to write to the object, that object, right? You want to send a file to that object. Well, you can do so by, contacting the socket, which by definition is a special type of file used for communication between processes, okay? So we can think of a socket. So a socket may be thought of as a communications endpoint. Basically. You can think of it, it's usually tied to a particular local system port to which processes may attach, okay? So that's the idea. So for instance, in some systems, there's a socket. So for example, in some systems, you might have a socket for the printer. So it's going to be dev printer. It's really a file, technically, but it's nothing more than a communications endpoint, okay? So it's used by processes to send messages to a program called LPD, which is the printer that I said. So, you know, LPD stands for the printer spooling daemon. But so you have this, and so you have a program over here, prog1. So it's used by the process to send, think of it, you know, and then you can communicate like that. Right, so you attach the program. The program basically calls dev printer, and then dev printer kind of communicates with the printer itself. Right, so that's another idea, another type of file that you have in the system, and it's usually the socket. Okay, and that just a socket really, you know, it's a combination of a port number, you know, some kind of an IP, etc. All right, let's talk a little bit about processes. So that's, you know, to wrap up some of the terminology, the miscellaneous terminology. We have also in Unix processes. Or a process. Okay, you're all familiar with, you know, that. Some of the commands for them you've already tried. In simple terms, so let's just say, provide a formal definition in simple terms. In simple terms, a process is a single executable program. So a process is a single executable program that is running in its own allocated space. In its own allocated space. Remember, you know, code basically with memory associated with it. So that's a process, and it's got some metadata also, right? So it's, you know, think of it as, you know, some code takes up some space in memory, and then it's got some metadata as well, besides the work that it's doing, that defines things about it, right? Related to, you know, access control and permissions and IDs. Who is running it is actually really important. So in simple terms, a process is a single executable program that is running in its own allocated space. Right, within this idea, we have a couple of terms that we should define. So as part of processes, we have the batch process. Now, you know, for instance, that you can run a script from the terminal, right? And that will become a process itself, right? But you can also have what is called batch processing. And in batch processes are the ones that are not associated with any terminal. So batch processes are not associated with any terminal. So these are the ones where we say, oh, it's just running in the background, right? So you say that, you know, the program is running in the background, so it's really not associated with a terminal. So they're really just submitted to a type of a queue, and from which jobs are executed sequentially, right? So that's just more of the OS, some kind of round robin algorithm, some kind of a thing like that, and it's just going to execute them, but they're all in the background. And those are usually the services, right? So these are usually, you can think of them as services that are running in the background that perform tasks and basically define a role for the server itself. Okay, so these, you know, These would be like Apache, etc. You know, all those names. Now, within that, we can define these as daemons. Right? So we can define these as daemons. Okay. And these are also, you know, batch processes, but basically daemons are server processes. Right? So we can just more formally define them as daemons are server processes, often initiated at boot time, which basically means when the computer starts, right? So often initiated at boot time. Okay, and they run continuously while the system is up, right? So that run continuously while the system is up. Okay, and they're just kind of there in the background. You know, they're the port numbers, right? So they're listening. You know, imagine you have a server, right, and you have several port numbers open, and they're associated with processes running there. So they're just waiting in the background until a process requires that service. So there's another one, you know, like a browser, right, wants to communicate to the port through port 80 with Apache, right? Or you have an email client, right, and it wants to communicate with email, right? So it's going to engage through that port number over there. All right, so that's basically the idea. So some important daemons, if we want to think of them. So some examples of daemons could be, you know, there's UNIX daemons. Let's say UNIX daemons. We have like syslog, which we talked about. Syslog, email, you know, printing, you know, web, right? Web services. So all the things that we know that we're familiar with. Now, the key thing is that whenever you call these services, to recognize the daemon, and this is important when we start to like look for things or grep information, is that we can say, oh, I want, you know, syslog. So the daemon for it is just going to be syslog D. So they usually have a D at the end of the service, not always, but can. So printing, you know, will be something like LP and then the D again, and so on, right? Cron itself, you know, which is another one, you know, in the background, the daemon is cron D. Okay, and so that whenever you see that should give you an idea. Oh, that's a daemon running in the background. It's pretty important. All right, so a few additional things. So I mentioned, as I was talking about the process, if we go back, I mentioned that a process has some metadata associated with it, right? So the process, let's call it the process metadata, and that's important for access control. So I'm going to go over here, and for a process, let's call this process attributes. All right, so we can talk about process attributes, and then we can say, well, what is the, and this is just, you know, again, the process, which is this, and what is the metadata associated with it. And metadata just means data about data, right? Or data about a thing. So here we have a process that's running. It's got some data associated with it. So some of the relevant information that a process will have is the process ID, of course. So you guys have probably seen that process ID. You do something like PS, you know, in the background, in the command line, and gives you information about a process, their IDs. This is usually called a PID. Right, and that's relevant. Like if you want to, you get a process, whatever, and then it's got an ID of, 112, then if you want to stop it, you can just say kill-9 1122. And then that kills the process in the Unix operating system. Another attribute that a process might have is what is called the parent process. All right, and this would be basically the process that spawned that other process. So that can happen where you have a process, something happens, and that spawns or creates another process. So that's called the process parent process ID, also referred to as the PPID. Right, so this is the process that created it. Another thing that's sometimes associated with this is something called the nice number. The nice number. And the nice number has to do with scheduling, okay? Some processes are more important than others, right? So something related to the kernel and the operating system, the functionality of the OS is going to have priority over, your script, etc. So the nice number is the process or the process's scheduling priority. Scheduling priority. So remember, this would be like when you take your 330 or if you've taken it already, this has to do that in the background of the operating system. There's some kind of a algorithm, round robin, etc., that allows to schedule all the processes in the queue, but it can look at the nice number to say, oh, this is more important. I need to give it priority. Any questions so far, guys?
I don't think so.
Pretty easy, right? All right, so a couple of last things related to metadata. One last thing related to metadata is what is called the real, and this is really important, by the way, and effective user ID. So this relates to who actually owns that process, right? Because whoever owns that process determines the access that process will have to other resources in the operating system. Like accessing other files, right? So if something should not be owned by root, then you don't want that process to be owned by root. As you probably know already, what hackers try to do is they try to find a program that is root owned, right, has full privileges, hack it somehow, right? So a hack, basically like a buffer overflow attack, means injecting code and then having that code basically spawn a new process. Let's call this process 2, this is process 1. And they want to retain this, right? So they want to carry that over so that they can have the root privilege. And of course, if they inject code, it means that they can create any type of process, such as a terminal. So imagine a terminal that it's no longer like this, but it is like that. That's that basically ends your control of that server, and it's being hijacked by someone, right? So this is pretty important because whenever you have a process, part of its metadata is what it is, 2 IDs, the real and the effective user IDs. So every process will have these, and I'll explain to you why that in a second, which will lead us to then another topic, which is also very important. So first of all, let's provide some definitions, right, of real and effective IDs. So the real ID real ID is going to be the real user ID, of course. And then we have the effective ID. Effective ID, and that's going to be the effective user ID. Okay, so these are the two IDs that would be associated with a process. So the formal definition is as follows. A process's real ID, or real UID, let's say, real ID or RUID, okay, is the UID of the user who started it. Who started it. So what that means is, let's say that I'm seed, right? So I'm just a regular user on the Ubuntu VM, and I start a process. Well, my real user ID is seed, which is 1000, number 1000 in the system, as you guys saw. And that's important for access control, because access control will say, okay, it's just a regular user that started this program, right? However, there is another element. There is the effective user ID. So what is the effective user ID? The effective user ID, let's change color here. The effective user ID, which is the EUID, is the ID that is used to determine the process's access. It's used to determine the process's access, or access control, right? And this access, of course, is to the system resources. So that means that over here, you're going to also have a effective user ID. Now, usually this should be the same, right? So you would think you would want them to be the same. However, there could be situations where something like this could happen. Can you imagine that? Your real ID is seed, but your effective ID, which is by definition here, effective ID is the ID that is used to determine the access, right? So the permissions are granted. Permissions are granted based on effective user ID, not your real user ID. So think about that. So can you guys give me a reason? What would be a reason for that? Can anyone think of a scenario? Why have effective and user ID? I mean, you either have permissions or you don't, right? So what do you guys think?
One could be a temporary role.
Like what?
Like maybe there's they're given permissions for one session or something.
Yeah, very good. That's a pretty good answer. That takes us actually to what is called set UID, which you probably remember I mentioned this before in the semester, when you go to a folder and you do ls, oops, you do ls-l, right? So you do that, and then you get some output. Well, remember what I said, you look at the files there, and you have like, you know, what is it? Read, write, execute usually, right? And then read, execute, and then read, execute. And, you know, dot, 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 right? So all the other information. But I mentioned that this one actually, instead of an X, could be an S, right? And that's a process that is set UID. And what that means is that that's a process, or that's a script, that's a file here. In this case, that's a file. So for instance, the file passwd, right? That script is basically a script that allows you to modify, let's say, a file, you know, a very important file like the shadow file. So let's imagine the scenario where we have a file, let's call it the shadow file. The owner of this file is root. Okay, the parameters for this file are basically the owner can read, write, and execute, but no one else can touch this file, right? Those are the access control parameters. However, what happens when you guys need to change your password in your Unix system? Can you? Like, let's say you're just, you're just, Neo, right? Neo account. And Neo account is not even an administrator. It's not in the sudoers group. So Neo needs to change his password, his or her, well, his password in this case. So Neo needs to access the shadow file. But the problem is the shadow file is what? Root owned, and only root can access. Do you guys see that, guys? Make sense?
Yeah.
Right. So what you need to do this is you need a program, in this case, passwd, and passwd then should read the file for you. But passwd is also owned by root. You see that? So root owns this file too. However, because it is set UID, the definition of a file that is set UID is basically that you can now set these parameters in a certain way, right? So you might see where this is going. What's going to happen is so now let's go to another one. If the file was not set UID, Neo would come in. Oops, change color. So Neo. So if the file is like that versus, oops, versus like that. So this one is set UID, not set UID. All right, so we've got Neo here. Neo wants to change his shadow file, his password. Shadow is owned by root. So that's going to be challenging. This file is owned by root. And this one is owned by root. Right? And it's going to be and this is going to, so as I said, you need basically a program that you can run to access the shadow file and change the password, right? Remember that this script also, that's this script, right? So, this one or that one, that scenario. So when Neo comes in and he runs passwd with these permissions, read, write, and execute, Neo will spawn a process. So now let's call this the passwd process with all its metadata, but in particular, what's relevant for us is EUID and RUID, right? So the real user ID and the effective. So the real user ID, the effective user ID, those are the two IDs that we have in the process. So that what's going to happen? Well, the real UID is the one that spawned it, neo. And because it is not set UID over here, this is going to be neo, right? So it doesn't achieve the objective. So when this process tries to access shadow, it will be, you know, denied. Now let's look at the other scenario. Neo comes in over here, spawns a process from past WD, right? So process, oh, sorry, not, it's a lot. Past WD process. But this time, this process, past WD, the file itself that will spawn the process in memory, which will have an ID, you know, like the actual PID, right? You will spawn a process, but what's important here is that the real user ID and the effective user ID, this time around, because this has been set to SS, or obviously that has to, whenever you do that command, you have to do it, I think the command is ch, can't remember, chmod 4755, I think, and then the file, let's say pass WD. I believe that's the one. So that will achieve converting, it can only be done by the owner of the file, root in this case. So the file has to be root owned, and then only root can run this. So technically this needs to be, you know, # because it's an it's the sudo or root itself. When that happens, however, it is neo that initiated. So the real ID is whoever initiated, but the effective ID, the effective UID, is the ID that is used to determine the process's access, right? And in this case, because of this mechanism, it will be root. And this time around, when root tries to access root, right, it will be allowed to do so. So that's part of metadata, and that, you know, is how effective IDs, user IDs, real user IDs, and effective user IDs, plus the set UID mechanism work. Are there any questions about this idea, guys? Any questions? Make sense?
Yeah, I think so.
All right, good. All right, so that's a question on the exam, right? So just make sure that you have questions, please ask. That is, you know, an important concept as we talk about processes in the operating system in Linux, which is really important for, again, all of it is security. All of it is security and access control itself, okay? All right, so next topic is we are almost to grep and Awk. So I think we're doing really good. This wraps up a lot of the miscellaneous ideas that we needed to cover. One recommendation for the lab this week and going forward, you know, Linux is very, you know, as you know, the Unix way, everything is a file, right? So everything is a file. And let's say you have, you know, configuration file, right? So something dot configuration. So a lot of configurations require you to change, right? You change what's in here, put in other stuff, and as you can see, as you start doing this, it can become, you know, and then you lose data, and then you break your program, and then what do you do? So one strong recommendation, in sysadmin, recommendation is make changes, and this is also in your handout, in your slides, make changes so they can be reversed. Okay? So don't try not to modify the original file. Instead, make a copy, right? So always make a copy. So for instance, let's say that you have, you go in, usually your configurations are going to happen in etc, right? etc in the file system, root etc, is where you have a lot of the configuration files, very important, right? And then before you modify, let's say the file something.configuration, do cp. What is cp? It stands for copy, right? So you're going to say cp something dot configuration, and then save it as something dot configuration dot, usually it's not a bad idea to just call it dot backup, right? That's perfectly fine in Linux. And now there are two different files. This one is still the one that Linux will look for, but you just have the original in there, okay? You have the original in there. You also want to check when you're modifying a file, always do, ls-l before. Run ls-l because you want to see if something is a symbolic link or not. Usually in the Unix operating system, it'll show like something like that. And this symbol, the arrow, indicates that it's a symbolic link, okay? So because you want to be aware of what it is that you're modifying or deleting or copying, basically. Okay? And then if you want to take it even, be paranoid and just take it a step further, you can even do, for that backup file, you can do chmod. If you remember, that's just changing the modes as they're called, right? And you could say write protect the file. So by doing AW, right, you're taking away the write permission for all. So you can say AW something dot configuration dot backup, and that's just to further protect that file so that you can keep it as your reference, especially if something is complicated and you're not too sure about what you're doing. I strongly recommend that you take a look at that idea. All right, so that's definitely recommended. All right, so I think we are almost then at the point where we can begin our discussion leading up to searching for things. So we're definitely not going to get to DNS today, which I figured, but we'll probably get started with DNS on Wednesday. All right, so we'll just kind of go with this one. So the next set of topics that we will cover are, and what I'm going to do here is, let me look at these, because for whatever reason, Zoom has a limit of 20 slides. I don't know why. I think these are pretty good. I think they're all, a lot of this, almost all of this is already in the other slides. I don't know if anyone can confirm that. But what I'm going to do is I'm just going to save this as a PDF just in case. So let me call this miscellaneous Unix. And I will be posting this on Brightspace. Give me a sec here. So, all right, so I saved that PDF. You have the video, but I guess if you... And then now I'm going to just clear the whole thing. I think I can do that. know that there's a button to delete everything. It's not taking care of that. All right, so I'm gonna okay, so I'll erase these as I go, but I've cleared up a few. All right, so now I'm starting like a new set, I guess. All right, so in this part, we're just gonna move into this idea of, you know, finding data in Unix. So what is this for? Let's say that you write all of your code, C files, Python, Perl, Bash scripts, right? You have them all over the operating system, your Unix operating system, the file system. And you say, oh man, I remember I wrote this function. It was so great. I needed to manage these servers now, this script, but I can't remember the name of it. However, I do remember something about it, right? So I do remember something about it. And so how do I find it, right? So that's the question there. How do you find data? And I don't mean just like help, like finding, help like from the man pages. But I mean like finding information, finding data in Unix. So there's a couple of tools that we can use for that. There's grep and awk, which are two separate things. There's also the find command and so on, right? So that's the idea. It's like searching for data. You can maybe search, we can call this searching the file system. Searching in the file system. Okay, so searching in the file system. That's really, that's really the idea of what we're trying to accomplish. All right, so now just, I guess, for completion here with the man pages, if you want to find, let's say, pages as separate files of specific programs, if you haven't tried already, go ahead on the command line and just do man, and then you type like, okay, I want to know about a process called umount. So we'll look at this one when we look at the file system, right? So it wouldn't hurt to start looking at it now. And then, another process, new FS, HDFS, and so on, right? So if you want to get all of those programs as separate pages, you can use the man pages. But that's a different kind of search. That's just like searching information in the man pages. But here, what we want to look at now more specifically is finding relevant information in the file system itself, right? So for that, we will look at the idea of grep and awk. Let's start there. So we'll start with that. Also, FYI, usually the man pages are stored in user share. This varies from operating system to operating system, but generically for Unix would be somewhere there. All right, now we are ready. Let's move on to, let's call this grep and awk. All right, and in particular, first of all, we're gonna provide a formal definition for grep itself. So let's say then the formal definition of grep is that it searches, so maybe I should say grep searches grep searches its input for lines containing a given pattern. Okay, so that's what grep does. Grep searches its input for lines containing a given pattern. So if you think about, if you dissect this, basically it's saying you need an input, something, right? The file system, the directory listing, whatever. You need a pattern, right, of what you're looking for in this place. So what am I looking for there? And then basically grep will return lines containing that given pattern, right? It's going to show you a list, and that's basically the process. So there's going to be some output, right? So, you know, you search the file system for certain things, you find them, grep gives you the output, and then now this output basically can be piped into something else, right? And that other thing that it can be piped to, as you might imagine, is awk. All right, so then, oops, it can be piped into awk itself. So awk over here becomes, it takes the output, right? Whatever the output is, it gets redirected to awk. So then what is awk, right? So that's the next thing that we want to define, is what does awk do with the output? But here basically the idea is that grep is a tool. We've used it already a couple of times, that searches its input for lines containing a given pattern. Just clearing up these. All right, so then we are here. All right, so we are ready then to describe, you know, this in a little bit more detail. All right, so actually, let's see. And I should say, you're going to get a homework on grep, right? So you will get a little separate problem on grep and awk, like a research grep and awk problem, homework. That's at some point. And this will be a research type of a thing. Well, you'll have to, I'll give you a problem. You'll have to write basically the grep and awk command for this. So then, you know, as we were saying, switch back to red. Users use grep to search files. To search for search files. So let's think of an example here. All right, so the best way to understand this is with a little example. All right, so let us say that we want to find out about all of a certain user's current processes. You know, so find out about all of a certain users current processes. All right, so that's what you want to find out about, right? Find out about all of a certain user's current processes. So you have to think about that. You want, from all the processes that are running in the system, you want to know which processes are the ones that belong to a specific user. So the question is, how do you do these kinds of things, right? So how do you quickly do that? Let's say that your boss, you work for a company or something, and they say, I want you to go to look at in these servers, please, and find for user so-and-so, find out all the processes that this user is associated with in all these servers. We need to analyze it for whatever reason. And it doesn't have to be a bad reason, right? It's a good reason too. Right, so how do you do it? Well, this will involve some kind of a Linux command. It might involve piping the output of the Linux command to a facility that allows you to search the output, right? And so, what do you guys think? What would we do? So one consideration is we could say, go to the terminal, and I'll just use the generic terminal notation. So I'll just say that. And we could say PS, which you guys probably already remember this, you already tried this in one of your labs, is the command to basically look for processes in the system. You can play around with the flags, but these should give us the right information, AUX, right? You can always look these up in the man pages. And so that gives us the flags for PS. And then that gives you basically all the processes that should be running in the system, right? And then now that's going to generate an output. But that output needs to be still searched so that we can find every one of those processes that is associated with the user, right? So in that case, what we want to do is we want to pipe that output into the next step, which would be to grep. And we're going to grep all the output that we just got and search for a pattern. In this case, we're going to search for all the lines that contain the word Smith, because we just learned that grep, you can see that over here, grep searches its input for lines containing a given pattern, right? So pretty much what we were talking about here, the generalization of this one is that it's going to be output from a command to grep, which will then pipe to awk. Okay, remember that we still haven't defined awk, but awk also serves a specific purpose. Okay, so then, where are we? Okay, so then going back here, yeah. So we grep Smith, right? And this will give us then all the lines from the processes which are associated with Smith, and now you have your output. So this would display processes that include the word Smith. Does that make sense, guys?
Yeah, it makes sense.
It's pretty easy, right? Pretty easy. All right, so this is the type of, obviously I will give you a problem related to this, and then you will do something like this, okay? You will do something like that. So these, as far as the flags here, the little flags, we can just say that with these flags, you get to display or list every single process in the system, okay? Every single process in the system. So now that we've thought about this, we can go back to the idea of awk, right? So what is awk? We need to provide a definition for that one. So let's say the awk command. All right, the awk command. So this one then needs also to have a definition. So here, and it's basically the way that I like to usually describe it, because it gives you the intuition of it. It's like Excel. So awk is like a little Excel where you now have the data, which the output is rows and columns, and you can now kind of process it like Excel. Summarize a column, you know, add this column and that column, get rid of 3 columns and just leave 1, get rid of these rows and just leave the ones that match this pattern. So Awk is really like a little Excel, but in Unix. Very efficient, very fast, so that you can do things here without having to write inefficient code. Okay. So then here you can say for the awk command, formal definition is that awk can be used to selectively manipulate the output of other commands. Okay, so awk here, as we can see, can be used to selectively manipulate, like Excel does transform, the output of other commands in a more general way than grep. In a more general way than grep. And it's actually really a huge topic. Grep and awk can literally be books unto themselves, right? So they're really very vast, very powerful. They're almost like this library in Python called pandas. They're extremely powerful at doing a lot of things. And so they're really impressive, to be honest. So if you find these impressive, you know, we're not, obviously we have a lot of topics this semester, but I've introduced you to the ideas. You can always, you know, get the books on grep and awk and just, you know, practice. You're going to find a lot of little problems and examples that you can work through. Okay. So now we've provided a definition of grep and awk, and the idea is then, so awk can be good for, you know, rearranging. So uses of awk, and these are just some examples, but they can be like rearranging columns in the input, you know, within the command input. So let's take a look at an example here. Let's just say example. All right. Just get rid of some of these. All right, so I think that's all of them. So now we can go back. All right, so here we are. So example, now introducing awk, and similar to before, we're going to do PS. Now let's say another set of parameters, EF. Now we grep, and we're going to grep for, let's say, you know, Jones, right? So just some other name. But then those lines that match that pattern are going to be piped, right? Piped into awk. And awk is just the awk command, and then, you know, some formatting or search in curly brackets command. So here we do print, and we say print only $1. Because remember, it's going to have its own notation, right? So this is, make that a little bit bigger. This is going to be print $1, close curly bracket, close single quote. So what this does is, obviously, we get the output of the processes. That's piped into the grep command. We search, and then the result of that is piped, and we just kind of, to all of the data that we got, we're going to filter it, basically. So this is a type of filter. A type of filter. And so this basically, this awk command, prints only the first field. The first field from each line. So in essence, the column, right? So from each line of the PS output passed to it by grep. So remember that PS outputs to grep, it pipes it. Grep searches for the lines that contain Jones, and it pipes that to Awk, and then Awk looks at all the fields, and it only returns the first field from each line. Therefore, basically, the column, and it discards everything else, so it provides a kind of a nice output. All right, so this is a very good stopping point for today. We will continue this discussion on Wednesday. So we will finish up this on Wednesday, and might look into other topics as well. All right, so if you have any questions, I'll stay over a few minutes. Otherwise, I'm going to stop sharing and, oh, wait a minute. No, I still have it here. I'm going to save this PDF. And I'll be posting this as well on Brightspace. So this was grep and Awk. As I said, I think you have this already, but just want to make sure. All right, so I've stopped sharing, and I'll stop the